let's try number 5. These two angles, we have to define some relationship between them. And so we have two intersecting lines here, and these are non-adjacent angles. They're across from each other. That means these are vertical angles. And by the vertical angle theorem, I know that these two angle measurements should be congruent. Or in other words, the angle measurements are equal to each other. And so that's what I'm going to use, that fact, I'm going to use for my equation. This angle equals this angle. Okay, so there's my equation. And now I'm going to solve this equation. Because I have this x squared, it's a quadratic equation, which means I need to move everything to one side and leave this set equal to 0. So to do that, I'm going to subtract 23x, and I'm going to add 4 to both sides. So minus 23x plus 4. That gives me a 0 on the right. And on the left, I'm going to combine like terms. There aren't any like terms with 3x squared, but 10x and minus 23x would combine to give you minus 13x. And then there's not another term like the plus 4. Okay, so here's my quadratic equation now written in standard form. So once I have it written like this, I might try and factor it. Now, my first two terms have to multiply together to get 3x squared. 3x and x are the only way that's going to work with whole numbers. Let's see if we can find the right combination of numbers to use here that multiply together to get 4. So of course that could be 2 and 2 or 1 and 4. Now, because this is positive, you could either have a plus 2 and a plus 2 or a minus 2 and a minus 2. Now, because I see that this middle term is negative, I know I'm going to have some negative signs. So these are both going to be negative numbers. So it's either negative 2 and negative 2, or negative 1 and negative 4. Of course, switching the order of negative 2 and negative 2 wouldn't change the factors, but if I switch the order of negative 4 and negative 1, that would be 2 different factors. So here are my 3 possibilities. Let's see if I can figure out which one will work. I know I've got to get a pretty big negative number, so I'm going to try putting the minus 4 over here, because that's going to get multiplied by 3. That'll give me negative 12, and then a minus 1 right here, because that's going to get multiplied by the x. So that's my outside and my inside terms. So let me check this. Let me see if it boils back together to get the preceding expression. So what is 3x times x? 3x squared. What's 3x times negative 4? That's negative 12x. What's negative 1 times x? That's negative x. And then negative 1 times negative 4 is positive 4. And if I combine these two middle terms, which is the outsides times the insides, I've got negative 12x minus x. That's negative 13x. So my factoring worked. Now to get my x values, which is what we're trying to find here, I'm going to set each factor equal to 0, so 3x minus 1 equals 0, and x minus 4 equals 0. And then I'm going to solve each of those for x. So x equals 1/3, and x equals 4. Now, are they both correct answers? Well, they both solve this equation, but that doesn't mean they give you realistic angle values. So let's check that. Some extra paper. Okay. We'll check our answers. So what if x is 1/3? Could that work? So that would be, this angle would be 3 times 1/3 squared. That's 3x squared. Plus 10 times 1/3. And 1/3 squared would be 1/3 times 1/3, which is 1/9. So 3 times 1/9 plus, and here 10 times 1/3 would be 10 thirds. Multiply the whole number on top. 10 thirds. And that's 3/9 plus 10 thirds. Now we could find a common denominator here. This will also reduce to 1/3. So it's 1/3 plus 10 thirds, which is 11 thirds, okay, for that angle. Do we get the same thing for this angle. So 23 times x minus 4. Let's find out. Okay, so 23, that would be 23 thirds. Third over 1, multiply on top. Minus, and so that I can combine these, I'm going to put this 4 in the thirds as well. So I need to multiply it by 3 on the top and the bottom, so minus 12 thirds, which is 11 thirds. So, does that give us two angle measurements that work? Yes, it does. What about for x equals 4? So if I plug in 4 for x, that's 16 times 3, which is 48, plus 40 equals 84. Oops. And for the other angle, we'll do 23 times x minus 4. 23 times 4 would be 80 plus 12, so 92 minus 4, which is, did I do that right? Let me double check myself. I got 88. Okay. Oh, no. Hey, I got 88 back here. I bet you've all been yelling at the screen, no, Mr. Simpson, 48 plus 40 is 88, not 84. And you were correct. Okay, so that matches as well. So both of those give us realistic angle measurements. So 11 thirds, although it's not exactly what you would expect as an angle measurement, it's a positive number. You could have, what's that? That is 3 2/3 degrees, so it would be a very small angle, but it is an angle measurement nonetheless. So our answers there are the x values, the values of